Applications of redox reactions. Redox reactions have multiple applications which have been observed in real life as well as in chemical industries. So what are the applications? Let's check out few of them. So first of all, we have the application in electrolysis. What is electrolysis? Electrolysis is the phenomena in which we take aqueous solution or molten solution of a salt and we put rods of electrical plates and understand the separation of metal ions as well as negative ions from a fused salt solution or aqueous solution. Alright. So what does that tells us about? We have observed that second law of Faraday explains about electrolysis, that the masses of substances separated out are proportional to their equivalent weights. Equivalent weights and their masses separated at different electrodes are in same proportion. If mass of one element is W1 and the another element is W2, then W1 by W2 is in proportion to their ratio of their equivalent weights. So this is a critical point which we need to understand. And what is equivalent weight? Equivalent weight is basically calculated by taking molar mass m divided by n factor, and n factor in a redox reaction is calculated by total increase or total decrease during a redox reaction. So total decrease or total increase in a redox reaction tells us about n factor. If we know the n factor value, we can easily calculate equivalent weight of a particular species. If we can calculate equivalent weight, then we can calculate gram equivalents. We can calculate gram equivalents of a substance, which equals to given weight upon equivalent weight. And where do we need gram equivalents? We need gram equivalents for the calculation of normality of a substance. Normality of a substance is calculated on the basis of gram equivalents. Gram equivalents, we put it here, gram equivalents upon volume of solution in liters. Volume in liters. So equivalent weight we need to understand redox reactions. Gram equivalent, again we need make the use of equivalent weight, for which we need to understand the n factor, and the redox reactions are required. Normality is equivalence divided by volume of the solution in liters. So for all these purposes, we need to understand redox reactions and how to calculate the n factor for them. So first use was in the determination of equivalent masses. Secondly, we need to understand in chemical industries, in refining of metals, in separation of metals, in extraction of metals, we do electrolysis process. And in electrolysis, the phenomena happening is a redox reaction. Alright. So redox reactions are very important in electrometallurgy. Electrometallurgy is basically refining of extraction of metal, extraction of metal from the source is electrometallurgy in a convenient and economical method. And electrorefining is again a process during the electrometallurgy or metallurgy of a metal, where we get the metal along with their impurities and we separate impurities and get the pure metal from electrolysis of that impure solution of that metal. And again we make use of redox reactions and electrolytic process. Electrolytic process is one of the methods which gives us a very pure percentage of the metal. Next, in electroplating. Electroplating is basically coating of a superior metal on inferior metal. For example, you must have seen women getting electroplated their silver jewelry with gold, or a copper jewelry or copper utensil with a coating of silver. So you can coat silver on copper and gold on silver. So this is called as electroplating, coating of superior metal on the inferior metal. So this is called electroplating. This helps us in preventing corrosion and degradation of inferior metals. This is also one of the methods to protect the inferior metals from getting degradation. Next, preparation of chemicals. From electrolysis of different solutions in the fused salt or in the aqueous solution, we can prepare many chemicals such as sodium hydroxide can be prepared by the electrolysis of a brine solution. Similarly, you can use different aqueous solutions for the preparation of different chemicals. Alright, and last but not the least, preparation of amines by the electrolytic reduction of nitrobenzene, you get aniline. Alright, and similarly other amine products can also be obtained by electrolytic reduction of nitro compounds. So these are few of the applications, few of the many applications of redox reactions. So this is it for now. Thank you.